In the previous video in this series, I assembled the carriage for the Curta calculator, and it didn't work quite as it should have done. When I tightened up the nut on the underside, the whole thing pinched up and it wouldn't rotate freely. I wasn't quite happy with the way it was rotating. It rotated freely and better than I expected, but it did have a few tight spots. And also, when I put the detent plunger and spring in, I couldn't really turn it. So it turned reasonably well, quite stiff, until it hit one of the two stop detents, but then I had to put a lot of force in to get it to carry on turning, and the pin on the plunger wouldn't come out of the little dimples that are there. So I wanted to address those things. I've now got it working much better, so it will come out. So it's now got the detent plunger and spring in, and as you can see, it comes out of the detents quite nicely, spins very freely, almost no resistance whatsoever, and then it pops into the next detent quite nicely. So the changes I've made to get it to do this is I reprofiled the little valleys that the pin sits in, and the top's now very slightly rounded, but also the lower section has a bit more of a curve to it. I decreased the length of the pin slightly and increased its end radius, so it doesn't sit quite as low in those valleys. And I shortened the spring by another millimetre, so it's not quite as firm, and now it comes out of those valleys and spins very freely. To stop it pinching up when I tighten the nut, this nut's now fully tight. What I ended up doing was machining about 0.2 millimeters off the inside face, that's the top inside face of the central core, and I also measured the thrust washer all the way around, about 6 points, and it was, I think, 3.21 at one side and 3.15 at the other side. Might not sound like much of a difference, but you know, the options are you could have it very loose, which I don't really like, but I decided I'd rather have it nice and snug. So there's no real free play in this, it's all quite snug, but it spins freely. So what I did is get some 800 grit abrasive paper, and then I carefully worked the thrust washer so it's now even all the way around. It's within about 0.02 of a millimetre the same all the way around. I then repolished the surface, re-lubricated it, and put it back together, and as you can see, the whole thing now works much better. And so what I'll do now is reassemble the carriage, and hopefully it will work better than it did before. I've also put the numbers on all the wheels. We'll have to see if they line up. I can always change them if we need to. And I've also found that putting a bit of PTFE dry lubricant on the threads of both these parts makes them screw together very easily. It takes very little force. So before, it was quite a struggle getting this to tighten up, and I couldn't even, without putting a lot of force in it, get it to screw all the way down. Whereas now it will screw all the way down with almost no force. I haven't changed it at all other than lubricating it. I've also adjusted the rivets for the clearing handle, so they now fit the handle. The two little recesses or cutouts very nicely. So I'll get this reassembled. I won't show it on camera, it's exactly the same process that I went through last time, but hopefully this time it will work a bit better. So that's the carriage assembled. Luckily the numbers do now line up. I moved them very slightly, about 5 degrees further round to the right. So it turns out, I meant to show you this before I fitted them, it looks like the correct location for the number strip is to have digit 6 centrally aligned with the pin or the pinhole, and once you put it in that location and then wrap it around, all the other numbers seem to be in the right place. As you can see, they appear centrally in the windows. So we'll set just a random number and see how easily this will clear. So hopefully you can see this. I realise in the previous video the numbers were being washed out a bit by the light, but we should be able to clear this fairly easily. Now it does have a stop pin in, and we are in one of the stop positions, so when I rotate this, when we first start rotating it, obviously we're going to clear the numbers around here, but we'll start rotating it, see how easily it moves, and hopefully, as you can see, it's taking pretty much zero effort to turn this. It's let's see, no numbers set now, so it's not doing anything. We'll set some more numbers to clear. Like I said, there's almost no effort required now to rotate this, and it stops where it's supposed to, so there's a detent there and one there, and it's stopping where it's supposed to. So that's looking very promising. Next step is to get this fitted onto the top of the calculator, and we'll start testing the interface between the two and see how well it works. The next step is to fit the carriage to the base of the calculator. Now before I do that, I just want to mention some very clever features of the design of the calculator. Some interlocks and safeguards that were built in a very clever way. Before I do that, I just want to point out another modification I made to the calculator from the STL files that I downloaded. And I'm not sure if the change or the omission was intentional by Marcus, or if he changed it for any particular reason. But I believe on the original that the drive from the crank, which is obviously this, you can see I've assembled this by the way. This is just a handle and a screw that runs in a slot. I'm not sure if when Marcus did the drawings and translated from the original design drawings, he made an intentional decision, but the STL files rely on the pin that goes through the crank handle and through a hole in the shaft to drive the calculator. Now if you're familiar with 3D printed parts, you'll know that 3D printed pins, even if you print them lengthwise, are not particularly strong. But also on the original calculator, I believe that the drive to the calculator was done through a cutout on the end of the shaft rather than the pin. And Marcus has actually, you can't see this, but he has incorporated that faithfully, the cutout at least, into the bottom of the hole in the crank. So at the bottom of this round hole is kind of a half step. And but the shaft on the STL has just got a flat end. Now you can probably see on the one that I've made here, I've modified it, and I've put a flat on the end for half of the shaft, so that fits into the cutout in the crank. So it's actually driven from this rather than the pin. The pin's just there to hold the crank onto the calculator and stop it falling off. Now, I'm not sure why the change was made, whether he was encountering problems with that, but we'll have to find out and see if we encounter the same problems. Now the first safeguard I mentioned, there's a 6mm ball sits in this hole, and the purpose of this is so that when the carriage is pulled up, the ball is kind of held in, and because the hole goes through into the tens bell, when the ball is held in, you can't rotate the calculator crank. So the idea is that when you pull up the carriage, which you do either to clear it or to rotate it into another location, you can't, with the carriage raise, then rotate the crank. So it's a safeguard to prevent the calculator locking up, because if you try and rotate mechanical calculators when things aren't in expected locations, then bad things generally follow. The other lockout we've seen already, which is the lockout when we change the mode of the calculator from addition to subtraction, and that's built into the bottom. I showed that in an earlier video. There are some other ingenious lockouts as well. So one of them is, this is the stop pin. So when we raise the calculator, we can change the column that is being worked on, and this pin hits this post, and there's another one around here to limit the rotation of the carriage. Okay, another ingenious lockout is this pin that's sticking out here is the bottom of the plunger that's used as the detent control for the clearing collar. So when we rotate this to clear the carriage, you'll see this pin will pop out. So it's now come out. We go all the way around to the next stop position, at which point the pin will go back down again, as it has there when the plunger drops back into one of the two recesses. Now the purpose of this is when we want to clear the carriage, we pop it up. We'll see this in a few minutes when I fit it. And when we start to rotate it, this pin comes out. So essentially it's a safeguard that prevents us from being able to turn the clearing collar when the carriage is down. So if you imagine this is in one of its two detent positions where it's in one now, if you want to try and rotate this, then that pin's going to try and come out. So it's going to try and pop down like this. But of course, when the carriage is all the way down, that pin will hit this surface, and it stops the clearing collar from rotating because it keeps the pin, the detent pin, in its stop position. So a very clever safeguard. It helps prevent rotating the clearing collar when you're not supposed to. Okay, so now on to putting the carriage onto the calculator. So the first thing we do is fit the ball into the recess. You can see it drops all the way in, but when we rotate the calculator, it will try to come out. So you can see now it's popped up. It's now, well, hopefully you can see it's popped up. It's now sticking up proud of the surface. However, if I rotate it all the way back to the home position, you'll see the ball will drop back down again, as it has. So it's now back down, but if the carriage is all the way down, then the ball can pop up into this space. There's a space in here for it. So when we pull the carriage up, then this portion of this sleeve will cover this portion of the this main shaft, and it will prevent the ball from popping out. And because the ball can't pop out, it stops the tens bell from turning, and that in turn stops the calculator crank from turning. So again, it's a very clever lockout. So we need to put that ball in place first. Next thing we do, I'll do this off camera because there's not a lot of space between the camera and the bench. It's not enough to actually get these two together. The camera's actually quite low down. So what I'm going to do is this will go on to this part of the calculator. We then put a thrust washer into this aperture. That's followed by a spring. So I wound this spring from 1mm piano wire. It gives about 300 grams of force, and the purpose of this is it holds the carriage down while the calculator is in use. So it just stops it from riding up while you turn the crank. So once the spring's on, this cover then goes on. This is compressed almost all the way down. And then we put the circlip on, and the circlip will latch into this groove on the end, and it holds everything in place. So I'll get this assembled, and we'll go from there. Okay, that went together quite easily. It's now all in place. So what we should be able to do is raise this by a few millimeters, and that will allow the stop on the carriage to clear the stop on the base of the calculator, and we can then rotate the carriage so it rotates nice and freely, and then it will pop down into the next location. But if we try and turn it too far this way, you can't see it. It's actually hitting a stop. You can probably hear it. And that's the home position. And it'd do the same thing if you turn it far enough and it hit the second stop. So that's in place. Next thing we need to do is fit the crank. And that just fits onto here. As I said, there's now a cutout in this, so it will only go on one way. So it goes on that way. And then the pin goes through the shaft to hold it in place, and then the calculator should actually be functional. So I'll get this fitted, put the pin in, and then we'll give it a spin and see what happens. Okay, that's the carriage fitted and the crank fitted. Now, as you can see, I haven't fitted the outer covers yet. There are two covers. In fact, there's three covers. There's one that goes up here, and that helps to support the carriage. So at the moment it will tend to flop about a bit because it's only mounted on the centre spindle. But normally it is supported around the outside. And then you've got the main cover as well that supports everything else. Then there's a bottom plate that goes on it. I've left these off because almost certainly this isn't going to work properly straight away because I haven't aligned these gears. I mentioned in an earlier video that I haven't yet aligned these select gears with the stepper drum. Also, I need to check that the other gears, because there are other gears as well, I need to check that these also align correctly with the stepper drum. And until I do that, it's probably not going to work correctly either. Digits won't turn when they should, or digits that shouldn't turn will turn. Now this is going to be quite difficult to show because I need three hands to do this at the moment, but what I should be able to do is raise this and then turn the clearing collar. Now when I'm turning the clearing collar, I can let go of this because it's held up. As I said, there's a kind of a captive element to it until I turn around to the next stop, which I have done. So that's now cleared, or would have cleared, the counter. We can bring this up again and turn this again. As I said, I need three hands to do this really. I'm just going to put it down and rotate it a bit. Okay, so if you pull this back up and then I try and spin this, again it's held out because it's on the stop pin. I can then rotate this, it will be clearing the main results dial, and you should see the carriage pop back down when it gets to the next stop position. That's one of the functions of that big spring, is to make sure that the carriage positively pops back down. So if we turn this round, you can see it's now popped back down, so that's working just fine. So that seems to be doing what it should do. Next thing I want to do, which I haven't tried doing yet, is turning the calculator with the crank while it's all assembled and the carriage is in place. I'm going to set a number. So we'll set 1.5, that's 1.5 set. Make sure the reversing lever is up, carriage is down. In fact, before we do anything else, we'll make sure we can still put the calculator into subtraction mode, which we can. I'm going to be putting a red collar around the bottom of the crank so we can tell when it's in subtraction mode. That's a job for a future date. So once we're in this position and we've got a clear results indication, we should be able to turn the calculator crank, turning nice and freely, and we should see 15 appear. Now almost certainly this isn't going to work the way it should do until we get all the gears aligned. We have however got 15 shown and it's stopped, although we have got, okay, those last three are fine. So it's done what it's supposed to. It's shown 15, but surprised. I didn't think the gears were that closely aligned, but it has hit the right ones. Hopefully you can see this clearly. It's quite difficult getting this into shot. If we turn it again, it should add 15 to this total, so we should end up with 30 in the results dial, which we do have. We've now got 30. Turn it again. It should add 15 every time I turn the handle, turning very nice and freely. Okay, and this time you can see it's hit this digit. It shouldn't have done that. It's just catching on the edge of the gear because essentially I've set all these slightly too low because it's quite easy to raise them, and it's harder to, if you want to lower them you can put a washer on these, but I'd prefer to just raise them all, and then I can just modify these pins at the bottom and have a nice easy solution. Now if it turns out every single gear is out and essentially it looks like the stepper bell is in the wrong place, the easiest solution for that is just to change the length of the supports, because that will effectively move the bearing plate up or down depending on whether you make the supports longer or shorter, and it will effectively move the stepper drum relative to the gears. But I'll go through, I'll do this off camera, you can't really see in there anyway, and I'll be going through and checking the alignment of all the gears on the stepper drum and I'll explain in a future video what I found and what I did. However, you can see that fundamentally this is working. What I want to do is keep going until we get to the point where it should produce a carry and see if that actually works. So the next one should produce a carry and increment the third digit, which it has done, and we've got the right result. You can see it's hitting, just now and again it's hitting other gears where it shouldn't do. It's not surprising, as I said, they're all on the lower limit of where they should be. So it appears to be working. It's doing what it's supposed to. Obviously that's only a very rudimentary test. I need to test the other modes, but it's too difficult trying to hold this and avoid doing any damage to it without the cover on. So that's it for this video. Hopefully you can see that this is now coming together very nicely. It's starting to look like a Curta calculator, and it's starting to actually behave like a Curta calculator. I think Marcus has done an excellent job in producing this, and it's looking extremely nice. So in the next video, hopefully I will have gone through, adjusted the alignment of all the gears, and we can start checking the actual functionality of the calculator and see if it actually works correctly. I'll also be working on the outer covers. Let's grab the main cover. So as you can see, the main cover needs some work. I need to tidy up this groove. This is where the decimal point indicators run, and then I need to rub this down. It's actually, I printed this in quite a small layer. I think it was 0.1 millimeter, so it's actually quite smooth, but you can see the lines in it. So I'll be rubbing this section down. I'm going to leave the knurled section. I think it looks quite nice as it is, but I will rub down the main section and paint it as I have done with the clearing cover, and it should look quite nice. I also need to relieve these inner portions a little bit. They're a bit too close to the digit wheels, and I want to smooth them as well to make sure that if they do touch, no damage occurs. Before I rub this down, I'm going to make an insert that goes in here, because otherwise I'll almost certainly snap one of these off. So I'll put something in here that will support these while I'm working on it. Once it's in place, it's fine. These are supported by this upper portion, but with it out like this, it's quite vulnerable to damage. But we're getting there. The calculator is coming along, and hopefully in the next video we should be getting fairly close to completion.